Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Jamadi. I would like to present about milling machine. First of all, we have to know the parameters which is we use in the measurement and the calculation. Such as, for example, we have height, width, length, cutter diameter, face mill diameter, depth of cut, and so on. Next, this is the formulas that we use in this project. For example, we have volume, machining time, productivity per 8 hours, feet per tooth, solid waste generation per kilogram, net power, table feet, and cutting speed. And then, this is the electric tariff that we use in this project. For the first 200 kilowatt hour, which is 1 to 200 kilowatt hour per month, the current rate is 21.8 cent per kilowatt hour. This is the algorithm that we use in this project. First, we start number 1. Number 2, define total volume after. Number 3, determine float milling A, B, C, D, E, F, G, H, I, J. Number 4, print F allowable thickness. Number 5, insert A, B, C, D, H. Number 6, print F parameter to be removed. Number 7, insert E, F, G. Number 8, print F total operation cost. Number 9, insert I, J. Number 10, if C is less than 30, calculate machining time. Number 11, calculate waste generated. Number 12, calculate output per day. Number 13, calculate total volume. Number 14, calculate total operation cost, which is output per day. Number 15, energy utilization. Number 16, calculate material efficiency. Number 17, else if C is less than 50 and greater than 40. Number 18, else if C is less than 70 and greater than 60. Number 19, repeat step 11. Number 20, else return. Number 21, show results. Number 22, insert string repeat. Number 23, if Y, repeat the process 5. And lastly, number 24, if N, the process N. This is the output that we get from this program. The results is part machining time is 0.95 minute. The total energy consumption is 8 kilowatt hour. Material efficiency is 100. The total operation cost is 1,539 ringgit and 79 cent. Solid waste generation is 0 kilogram. Estimated productivity per day, which is 8 hours, is 505 pieces. That's all from me. Thank you.
Hello, my name is Jimbun. Today I will be presenting the Let Me See C code programming. Conventional machine. From the task given, we have to choose 3 conventional machines to develop a C program. Firstly, we chose conventional lathe machine to use as a method to develop a program. Conventional lathe has big power, rigidity, spindle speed range, apply force or cutting speed, can be completed in a variety of shaft and these type parts of the external cylindrical surface. Conical surface, facing, turning, milling, drilling, cut off, and many more. The knife can cut short-cut vehicle continual feet and fit on the turret motor complex exercise can cut the long cone, excellent for large complex parts and can show superiority. Facing operation. Facing on the conventional lathe uses a facing tool which is a flat surface perpendicular to the workpiece rotational axis. A facing tool is mounted a tool holder that rests on the carriage of the lathe. The tool will then fit perpendicularly across the part's rotational axis as it spins in the jaws of the chuck. A user will have the option to hand feed the machine while facing or use the power feed option. For a smoother surface, using the power feed option is optimal due to a constant feed rate. Facing will take a workpiece down to its finished length very accurately. Depending on how much material needs to be taken off, a user can choose to take roughing or finishing cuts. Factors that affect quality and effectiveness of facing operation on conventional lathe are speeds and feeds, material hardness, cutter size, and how the part is being clamped down. Turning operation. The turning operation requires a conventional lathe machine, workpiece, fixture, and cutting tool. Turning is used to produce rotational, typically axis-symmetric parts that have many features such as holes, grooves, threads, tapers, and even contoured shapes. This can be done on the external surface of the part as well as the internal surface. Due to the high tolerance and surface finishes that turning can offer, it is ideal for adding precision rotational features to a part whose basic shape has already been formed. There are many more to the operation, but then it is available in our report. So this is part of my uh, calculation, which is the problem statement to how to produce the program and calculate the formula before we start programming. And then after recording, which is long words of codings and whatnot, it is available in the report, and this is the outcome after the programming is done. Here you can see this is the C code output for the interface, for the first interface, and then this second part, this is where we can choose a parameter what we want to do. We want to do a straight turning or a taper turning. Then it is followed by parameters for straight turning. Then we can key in all these parameters, let's say 30 millimeter, 20 millimeter, and diameter and depth of cut and everything. Here is the options for parameter for straight turning, and this one is the parameter for taper turning. All the codings, everything are available in our report. This is a short presentation, and then this is the exit output. So that is all from me. Thank you.
My name Muhammad Rahman bin Muhammad Nizar, and my message number AD190142. I will present about drilling machine. For the first one is the machine specification. Maximum drilling capacity 35 mm, max tapping capacity 20 mm, spindle stroke 150 mm, have a 12 steps of spindle speed. The spindle speed within 70 until 2600 revolution per minute. The column diameter 140 mm. The dimension for length 700, for the width 1150, and for the height 2150 mm. For the net 670 kg, and the gross weight 730 kg. This is for part design and operational analysis. For the operational analysis, the first, to decrease losses. Make sure tools are used carefully and make sure the hole make is accurate. Second, to increase the numbers of production, double product revenue, and increase machine speed. Algorithm. The first is start the machine. Second, user need to enter the parameter value length, width, drill diameter, thickness, feed, and approach distance. Third, drilling speed of machine will be 180 mm per second if diameter of drill within 1 mm to 2 mm. Drilling speed of machine will be 150 mm per second if diameter of drill within 3 mm to 6 mm. And drilling speed of machine will be 130 mm per second if diameter of drill within 7 mm to 10 mm. 4. The program will display the machine time, the total energy consumption, estimate productivity per day, total operation cost, and energy utilization. 5. And begin with start and go to the insert parameter with drill diameter, thickness, feed, and approach distance, and go to the diameter to and below. If yes, they will move to input 1 and display 1. If not, they will move to the diameter 6 and below. and if yes, they will move to input 2 and then to the display 2. If not, they will move to the drill diameter 10 and below. If yes, they will move to input 3 and display 3. If not, directly to N. This is for calculation formula. First, to calculate total energy consumption, the formula numbers of hours times number of days times capacity of appliance expressed in watt over 1000. Second, to calculate estimate productivity per day, the formula total output over total input. And the last one is to calculate energy, the formula power times time,